All right, so we're going to be talking about how do we actually design our databases. Some important things that we need to keep in mind are obviously what data types we need. So we've dealt with that with some of our past challenges. But now today we're going to talk about relationships between multiple tables and also constraints that we can add to define those relationships. Just a quick review, why do we need databases? I think Jake and Jack cover this and Raphael cover this as well. We need to store data between sessions. So that's the idea of persistence, to share data between applications. So again, you could have, Facebook app and a Facebook Messenger. They might share the same data. So they might reference the same database, even though they are two separate apps. Maybe we want to access and update large number of data records. So again, CSV files, not the most flexible or easy to work with. Databases offer ability to kind of update records in bulk and also give us some data security and integrity via adding some checks and constraints and all that good stuff. All right, so when we're designing our databases, we should be creating sensible tables. So the idea here is very similar to OOP design. We don't want to create one class that does everything for us. It should be separated into different ideas. So we have like a school idea of a school and the idea of a student. Those should be two separate classes that should not be all nested in one class. The same goes for database design. We should create a separate table for school information and a separate table for student information because those are two different concepts. We don't want to merge all these records into one table or all the columns into one table. Again, to make it modular, piece it out, try to separate logical units when you're creating database tables. Again, we also want to be mindful of reducing duplicate data. So again, our code should be dry, our database structure should be dry also. So we should not be repeating information between records. And that's something important for proper database design. All right, so pretty simple process. I'm not saying it's easy, but these are the 3 steps we should think about. So the first thing is make sure you take the time up front to think about your design. As Jake and Jack mentioned, you don't want to be messing with your schema often. Sometimes that's really difficult to do once you have data set and you might need to change stuff about your schema. Not always easy to do on the fly. So the worst thing is where you got to take down your database and users lose connectivity. So make sure you take the time to properly think about what your design needs to be and what you need to achieve before you try to implement your database design. So step 1 is just think about it, draw it out, sketch it out, make sure you have all your bases covered. Step 2 is create your entities, also known as models or also known as tables. So figure out what pieces of data you need. Like, do I need students? Do I need courses? Do I need, school information? These are your tables you're going to create, also called entities. So if you've heard of ER diagrams, those are entity relationship diagrams. The E is entities. The R, which is step 3 here. All right, once you create your tables, you got to figure out how your tables relate to each other or how the records within the tables relate to other records in other tables. So step 1, think. Step 2, create your entities. Step 3, create your relationships. We're going to be learning about what types of relationships we could have between tables. All right, any questions up until this point? All right, yeah, let's keep going then. All right, so let's talk about constraints. So there are multiple types of constraints you could add to your database tables. These are the main ones. There are other ones like we've seen not null. That is a constraint that you can add. You can add check constraints, which make sure a value is greater than some preset value that we have. Those are constraints that exist and you could add to your database tables as you need them. But the 3 that we're going to focus on today are primary keys, foreign keys, and unique keys or unique constraints. You might see that listed differently. But these are the 3 that are of interest to us today. So we've talked about primary keys a bit before, and this is just the key that is the main identifying piece of information for your data records. So you have a table, you need some unique way to identify them. You should almost always have an ID. Again, it does not need to be a numeric ID. You can use whatever column or columns. Again, you can have multiple columns as part of the key to make it unique. So now, for example, let's say we had a students table. We could use first and last name in conjunction as our primary key, but that's not secure because there are people with the same names out there, right? So that we need to get into maybe middle initials. Again, it's not guaranteed to be unique. So even though it might seem sensible that first and last name, like in our cohort, we don't have any duplicate names, first name, last name, that's not unique enough. So that's why we almost always use IDs, because IDs are going to be unique. We're going to have 1, 2, 3, 4, 5, all the way up to like 7 million, whatever number of records we have. And each one of those should be unique within our table. So kind of get used to that. IDs are going to be the main way we achieve primary key values, but they don't have to be IDs. As mentioned, every table in a relation database should have a primary key. Yes, it is theoretically possible to have a table without a primary key, but not really useful in a relational database sense. So just always create a primary key. Let's just make that a rule of thumb. Important thing is that your primary key value columns cannot be null. So that's something that's built in. If you have a primary key, it must take on a value. Null is not acceptable because that's not a unique identifier. All right, so in addition to primary keys, we can add foreign key relationships. And this is how we kind of connect two tables together in terms of relationships. So let's say we had a students table and an addresses table. I think that's something we worked with in our past example. Well, in that case, we're going to create a foreign key from one table to another so that they're kind of linked up, right? So we saw that students have address ID as part of the record. That ID should be a foreign key to the addresses table, which means that that record needs to exist. So if Leopold has address number 4, we must have an ID or a primary key value of 4 in the addresses table in order for that to exist. We can't just have, Leopold had address 4, but then our addresses table has no idea of what, address ID 4 means. So that's how we enforce data integrity, that we can't just make up IDs and say, yeah, this student has ID 77 for their address, but address 77 does not exist in the addresses table. Foreign keys will guarantee that that relationship exists, or you'll get an error saying, hey, ID 77 does not exist in the addresses table. So that is a safety check that we need to look into. Additionally, you could have unique keys. And the things I have in parentheses are just common namings for these values. So UQ is used for unique keys. I'm not sure why it's not UK. I think some people might use UK. I've seen UQ more predominantly. So that's just, again, a suggested naming convention, not mandatory or required. But unique keys are a key that enforces uniqueness outside of your primary key. So your primary key is going to be unique. That is guaranteed. But let's say you need some additional unique information in a given table. You could add additional unique keys that make sure that no value is duplicated within that table. And we'll see examples of all 3 of these with our example shortly. Any questions on primary keys, foreign keys, or unique keys? The important thing I want to stress is that any one of these keys can be made up of multiple columns. It's not always one column is a primary key or a foreign key. You could have a combination of columns that act as a foreign key or a unique key in conjunction. I know it's probably kind of hard to conceptualize or understand that fully, but we'll see with our example. Kat, you have a question?
Yeah, so like in the examples that we just did, those were not like actually foreign keys. You have, even though they function like foreign keys.
Exactly.
You have to do something. Okay.
Yep. Yeah. So we assumed that there was some relationship between like our addresses table and students table, but we didn't actually define those within our database. We just kind of like, as humans, we're like, yep, these link up in our minds, but our database actually needs a formal definition of a foreign key to enforce that for us. Because if we go back to our challenge, I don't think I have that up, unfortunately. Let me see if I can bring it up. Nope, that's not it. Sorry. I have it somewhere, I promise. Sql Basics, I think. All right, I think I closed it. This is what we had for Sql Basics. If we remember, take a trip down memory lane. Our seed data, like right here, when we added a new student, notice that I guess Leopold didn't have an address, but Andre over here, we said ID 4 was the address ID for Andre. Now that is, we're mentally saying, all right, well, that's going to refer to this address right here because this address has a value of 4. But there's nothing telling us that this has to exist. I could put value 77 in here and this is going to work, but it shouldn't because address 77 is not an actual address record that exists, right? We only have address 1, 2, 3, and 4. So right now, as it is, our Sql Basics challenge, we don't have proper design because we're not enforcing correct relationships here. And that's what foreign keys will achieve. So if I had a foreign key between my students table and my addresses table, this would rightfully throw an error. And that's what I would want, because I don't want to have some record that's referencing something that doesn't exist. That would probably cause problems elsewhere down the line. So if I could get out of this. Sorry, I have a lot of windows going on here. Okay, so let's talk about relationship first, and then we'll talk about an example here. So there are three main relationships that you can have between two tables or two columns. You can have a one-to-one relationship, you can have a one-to-many, or a many-to-many. These are only your three possibilities. So a one-to-one relationship means that a record in table A may be referenced at most once, or one and only one time, by a record from table B. So you can never have more than one reference to the same record in table A from a record in table B. Once you refer to one record, that record's kind of used up, and no other record in table B can refer to that record in table A, and vice versa. It's kind of like a one and only one pairing. This one is more rare. You're not going to see this very often. You probably won't implement this very often, but you can have one-to-one relationships where you have two different tables that kind of rely on each other. And they technically could be combined into one table, but you might separate them for design purposes. But they still want to be a one-to-one relationship where, again, if you have a record in table A, there's going to be at most one record in table B that matches it based on some column that you're specifying. One-to-many, you will see this very often. This is where a record in table A may be referenced one or more times by a record in table B. So a common example might be, let's say we have a courses table and we have, what's an example? Like a professor table and a courses table. Well, a professor can teach multiple courses. So a course, let's say we have course CS 101. Let's say that's taught by Raphael. So the course table would have a record with a foreign key that specifies that Raphael is instructor for CS 101. Now, Raphael can teach other courses, but we're going to dictate for our needs here that a course can only have one instructor or one professor. So let's say Raphael teaches also psychology 102. Then that record also can refer to the same record in the professor table, referring to Raphael. So CS 101 would say, all right, what's our foreign key? That foreign key is pointing to Raphael's record in the professor's table. Psychology 101 or 102, whatever, can also refer to that same Raphael record in the professor's table because he teaches both courses. So that is an example of a one-to-many relationship where your courses can have multiple records that refer to the same single record in the professor's table. So table A is what's being referred to. The foreign key would exist in table B because that is what is pointing to table A or referring to table A. Additionally, you could have a many-to-many relationship, and this is where records from table A and B can refer to each other multiple times. Really good example, we already saw this actually with our school example. Enrollments is an example of a many-to-many relationship. Why is that a many-to-many relationship? Well, you're combining courses and students. So students can take multiple courses, right? I can be enrolled in art, 103, history 202, whatever, as many classes as I'm allowed to take. I can be enrolled in many different classes. I'm not limited to just one class that I could take. Likewise, one course can be taken by many different students, right? Like I could be enrolled in art 102, and John Price can be enrolled in that class, and Porphy can be enrolled in that class. So we're not limited that one class has only one student. So in this case, one class can have multiple students, and one student can have multiple courses. That is where we achieve our many-to-many. It's basically a combination of one-to-many from both sides, which gives us the many-to-many. Right? So again, if you think about enrollments is basically combining the idea of students and courses in the framework that one student can take many courses and one course can have many students, hence the many from both sides there. What questions do you guys have about one-to-one, one-to-many, or many-to-many relationships? Jesse.
You're going to show examples, right? Because I think I'm having a hard time like conceptualizing it.
Absolutely.
Okay,
Examples. Oh yeah, slides aren't the best way to do this. I just want to give an introduction here. But example, we're going to get to it in a second. Jesse, did you have a question, comment?
It was the same thing. Just
All right.
wondering if there was visual aids.
Yeah, I feel like we're probably losing some students with these slides. Let's actually get to an example here. So quick, one more slide, I promise. How do we create these relationships? So we talked about constraints. So if we want to create a one-to-one relationship, there are two ways you can go about it. One is you can create a primary key combined with a foreign key, or you can create a foreign key combined with a unique key. Again, these are more rare to create, but it is possible with the constraints we talked about. The easier ones and the more common ones are one-to-many. You'll just create a foreign key. So again, table B would have a foreign key that refers to table A in the event that table B is referring to multiple records in, can refer to records in table A multiple times. Many, you need to create something that's called a join table. And we've actually seen this again with our school example, but we'll talk more about join tables and why that's necessary. All right, let's get to an example. So obviously all that was probably kind of confusing. Let's talk about Facebook. I'm not a huge fan of Facebook, but they have a pretty good model here. So let's talk about posts and comments and understand what entities we need to create, what relationships we need to create to fulfill what we expect Facebook might supply. So for this, I'm going to go to the drawing board. Again, usually pen and paper or pen and pencil work better, but in this case, we're going to be online. So I'm going to quickdatabaseddiagrams.com. This is a free site that lets you kind of create some schema visuals. And this is going to kind of aid our design to understand what tables we need, what relationships they have, and then we'll create the schema after that. So first we're going to diagram it and then convert that to SQL to fulfill what we want. All right, so again, this takes some reading documentation on how to work with them. So they have pretty good documentation to walk you through it. So you don't need to memorize this. This is not required. It's just for our visual demonstration purposes. Let's create some tables. I'm going to create a user account table. And then what fields do we want in that? We probably want an ID. That's a primary key. What else do we want? Again, what I'm writing here is not SQL. It's just a special language for the site to create some items. So we want probably a username. That's going to be varchar something 64. Password. So this is how they log in. They have an account, and we have that stored on the back end as username, password, maybe a last login date. All right, so this is what our table kind of looks like. They're just showing us our fields and the values for them. So we probably want int here. So our ID is going to be integer. That's our primary key. We also have username, password, login date. All right, so that's one table that we're going to need to create. Let's create another table. Let's create a user profile table. And then this is going to have an ID, as always. Let's say it's going to refer to a user ID, and we'll talk about why in a second. It's going to be integer also. I don't know, let's say they have a profile photo. And it's going to be a varchar. Let's say the URL can go up to 255. Hopefully that's big enough for us. All right, so we have user accounts, user profiles. What else? All right, so we're going to create a post table. So let's talk about these two first. So we have user accounts and user profiles. These could be combined into one table, but the idea here that I'm thinking of is user accounts. We're going to use that much more often, and we're not going to always care about like the profile photo, or I don't know what else we have, like personal quotes. I don't know what profiles have unique to them on Facebook. I don't use Facebook very often. But again, all this information may not be necessary for login details. If you are familiar with Facebook, you can log into like various sites just using Facebook's login credentials. So it's probably going to want to look up information in this table without caring about your profile photo or your personal quote or anything that's more specific to your user profile as opposed to your login credentials. So that's why I chose to separate it out. Again, that was a design decision. As with class designs, any design decision you take, make sure you can back it up. So in this case, my reasoning was I'm going to use my login information across the board. My profile information is going to be less used. I'm going to separate that out into a different table. All right, we're going to have an idea of creating posts. If I go on Facebook and want to say, hey, this is what I ate for lunch, well, I could create a post. That's what posts are going to create or contain. So I'm going to create an ID integer PK. The post will have some content. So that's going to be a text field, let's say. And what else would we need for posts? We probably need a user that wrote the post. Let's call that author ID. That's going to be int. All right, so we have posts. We have, again, a unique identifier for all posts created by everyone. So again, there's probably billions of posts out there. There needs to be an author for each post. And then the post is going to have some content, like the actual text that we are writing in. So we should be standard with that. Okay, what else can we have? We could have comments. So, if I write a nice, funny post, maybe someone wants to comment on it. That's what a comment will refer to. So we're going to have ID int. That's going to be your PK primary key. We're going to have the post that we are replying to. So that's going to be an int. What else? We're going to have the contents for our comments. So that could be text. And then we also need a commenter ID. Let's put that. Commenter ID is going to be int also. So just to highlight here, unique identifier for every single comment ever added to Facebook is what the ID will kind of keep unique. The post ID is what post that we're commenting on. The commenter ID is who's writing the comments, and the content is just what they actually are writing here. All right, so let's go with these 4 tables for now. I don't want to make this too complex right now, but we have 4 tables, and these are our entities that we created. Next step we want to do is, what are the relationships between these tables? All right, so if we think about user accounts and user profiles, these are 2 tables, and just the way Facebook works, or at least the way I understand Facebook works, one user is not allowed to have multiple profiles on Facebook, right? I can have at most 1 profile, and therefore the relationship between my user account, like my credentials to log in, and like my profile details, like profile photo, everything that's on my profile page, that is going to be a one-to-one relationship, right? I am not allowed to have multiple profiles, nor is a profile allowed to have multiple user accounts. So again, these are the questions we're asking. So again, if we want to go to our slides, what is the relationship between users, against accounts and profiles here? So we got to ask important questions, and you ask basically from both sides. So the first question we ask is, can a single user have more than 1 profile? Based on the way I know Facebook works, again, ignoring like business profiles and whatever other magic profiles you can have, personal profiles, can a single user have more than 1 profile? The answer is no. I can have only 1 profile created for my Facebook account. Then we go in the reverse side. So then we ask the opposite question from profiles to users. Can a single profile have more than 1 user associated with it? So like, can a profile page be for both myself and my houseplants? The answer is no. That is not allowed in Facebook's model. Each profile has 1 user tied to it. So the answer to both these questions is no. And therefore, this dictates that we have a one-to-one relationship, right? Because a profile can have at most 1 user, and 1 user can have at most 1 profile. You cannot have multiple, so there's no many in this equation. So it's a one-to-one relationship. All right, so since this is a one-to-one relationship, we have a solution here. Our solution will be to create a foreign key in profiles and reference the other table. In this case, we go from either direction, but then we also want to create a unique key to make sure it's unique. And we'll talk about why that's necessary. So in this case, for my design here, I've decided to create a user ID field in my profiles. So the foreign key is going to go from user ID over to ID over here. Now, this is not fully correct. This has created a foreign key. If you kind of look at the pseudocode over here, this is saying that my user ID is a foreign key referencing my user accounts.id. Now, the problem with this is a one-to-many relationship. Foreign keys by themselves specify a one-to-many, meaning theoretically, I could have multiple user profiles that refer to the same exact user account ID in my user accounts table. But since we do not want that, we want that to be a one-to-one. So we need to actually change it so that we have a one-to-one. So it's kind of hard to see, but notice that there's dashes or crow's feet based on the relationship I established. So here, a one-to-many, just using a foreign key. Notice that there's like 3 crow's feet here. Can you guys see that here? That's specifying that it's a many relationship on this side. Versus this has a dash, a single dash means it's a single relationship. So it's a one here, it's a many here. I'm going to pause there because I want to make sure we digest that. Again, we do not want a one-to-many relationship between user profiles and accounts. So we're going to make that a one-to-one. Now this is pseudocode, so we're going to have to understand how to do this in a bit. But understand that we need a foreign key plus a unique key. That unique key will sit on the user profile section saying this user ID can never be duplicated among every record in this table. So we have a profile 7 that refers to user ID 12. Well, then user ID 12 can never again show up in any other records here, else that's violating our design here. Because that otherwise I would say, we have multiple profiles that tie to user 12. That's not what we expect here. So again, this is going to be a one-to-one relationship that we create. And that's what's modeled here. Notice that there's a dash here, or a slash right here. It says this is 1 on this side, and this is 1 on this side. All right, let's get to posts. So the question is, what's the relationship between users and posts? Again, so we're just trying to establish what type of relationship we have, and then we'll implement that with SQL in the second phase of this. So the first question we ask is, can a single user create multiple posts? As in, am I allowed to go onto Facebook and create a post about what I had for lunch? And then maybe later on in the day, I want to create a post on what I had for dinner. Is that allowed based on Facebook's model? The answer is yes. We're not limited to just one post ever. A single user can create multiple posts on Facebook's platform. So that's answer is yes. This is a many relationship on this side. Now the question is, can a single post be created by multiple users, or can they have multiple authors? As far as I understand Facebook, that is not allowed. One post can have at most and exactly one user. So in this case, the answer is no. A single post cannot have multiple users, so that is not a many relationship from this side. Since we have one yes and one no, that is a one-to-many relationship. Meaning a user can create multiple posts, but a post cannot have multiple users. To create a one-to-many relationship, we simply need to create a foreign key in our posts table referencing the users table. All right, so we go back to our diagram. We're going to take the author ID and point to the user ID. So notice again, we have crow's feet over here, meaning that many. So you could have multiple posts by the same author or the same user ID. Because again, I can create 12 different posts just like today if I want to. There's no limit as far as I know for Facebook. So I can create multiple posts, and the author ID can reference my user ID multiple times from my user accounts table. I want to make sure we're not going too quickly. So let me pause here. What questions do you guys have about a one-to-many relationship, or how we achieve that in SQL?
I'm curious, got a quick question.
Sure.
So I was a bit confused about the difference between the unique key and the foreign key. Do you mind go over that a bit?
Yeah, absolutely. So unique key will say this value can never appear more than once. So we're going to apply a unique key on user ID for our profiles because we do not want a profile to reference the same user ID more than once. So we will set up a unique key saying this field will never be duplicated in this table, or this value, sorry, will not be duplicated in this table. A foreign key is different. A foreign key says my value is referencing some other value, usually in some other table. It can be in the same table. That's a little more rare, but this is saying this user ID needs to match something in my user accounts table. So if I have, let's say I have 3 records. Let's say Yulin, you have a record 1, you're ID 1, I'm ID 2. Let's say Suruchi is ID 3. Now, if we have a user profile, user ID must point to either ID 1, 2, or 3, because those are the only users that exist in our system. That is what the foreign key is saying, is that this ID value must be 1, 2, or 3 if we only have 1, 2, or 3 as valid IDs in our user accounts. If we tried to put user ID 4 here, that would be an error with our design, and that's what we expect, because we don't want to have a user profile that says, all right, this profile belongs to user ID 4, which doesn't exist in our system. That's not sensible data. So again, a unique key says, hey, this value should not be duplicated within this table. A foreign key says this value must exist in whatever column that we're referencing in some other table.
So does that mean the user account ID is a foreign key? Sorry,
So the user account ID here is the primary key for this table. We're going to have a foreign key in user profiles that references that primary key. So if you kind of look at the pseudocode here, this is saying user ID is an integer field. We're going to have a foreign key relationship that is going to refer to the ID in the user accounts table.
Okay, so basically foreign key and unique key, they all exist in a different object that referring back to the primary key was defined within the account.
Not quite. So again, there's a difference there. Unique key does not refer to any primary key. Unique key is sort of like creating another primary key within your table, but it's not the primary key. It's just some other column that's going to be unique. Your primary key field has to be unique. You can never duplicate your primary keys. In addition to that, if you need other fields to be unique too, for whatever needs, that's why you create a unique key. That's a kind of a supplement to your primary key for other fields.
Okay, thank you.
But it has nothing to do with your primary key. It's just another field that has uniqueness. Foreign keys refer to primary keys in other tables. So in this case, user ID is referring to the primary key of this table so that they kind of match up. I see a lot of hands raised and a lot of confused faces, so I think we definitely should spend more time on it. John Price, you have a question?
Yeah, the syntax in your pseudocode over there, is that what we're going to use when we're writing our schema with the hyphen and then just the account that the foreign key is referencing?
No, good question. So this is pseudocode for this specific site. So I'm using quick database diagrams. This is their syntax. So you can read their docs. Their docs kind of specify how you create these things. They give you good examples. This is purely for design purposes, not anything you need to learn or worry about. I'm just creating, again, these tables for visuals and the relationship. These lines tell us the relationship between these tables. So in this case, user accounts and posts has a one-to-many relationship that's denoted by the crow's feet here and using a foreign key here. Andrew Tran.
Why can't you connect user accounts to user profiles just by their IDs, just by their primary keys?
Yes, so great question. You can do that if you remember from our slides, which were totally confusing. Where is it? There are two ways to create a one-to-one relationship. One way is the way I showed, which is a foreign key and a unique key. You can tie primary keys together and create a foreign key. So the idea here would be, instead of having a user ID field, I could just delete my user ID field and then say that my primary key is also a foreign key. Let's see how this works. I'm not sure how the syntax works in here. Let me try to draw a line here, see what happens. But yes, you can have a primary key that is also a foreign key to another field. Yeah, there we go. So that's the syntax I'm going with. So now we're saying an ID here must match the ID of user profiles. This is slightly different design, but we're saying user profile with ID 723 is going to match user account with ID 723. In this case, those IDs will line up between both these tables. The way I had it before, the ID of my user profile has no impact on my user accounts table, or vice versa. It's a user ID field that I had, which must match my user accounts.
Are both of them considered foreign keys to each other?
No, in this case, only this one's a foreign key because it's referring back to the user accounts. My user accounts is not referring to my user profiles in any manner. So this is kind of like my source table, and then this table is dependent on that table for the relationship. It's only one way. We don't need to set the relationship on both sides.
Awesome, that makes sense.
I saw
Because both sides, it would be many to many, right?
Yeah, if we needed relationships on both sides, we'll get to many in a second. I saw a bunch of hands up earlier and they kind of went down. I don't know if I answered the question or you guys kind of just lost hope here. Okay.
I have a quick question. So why did you in the first place create user ID and ID under user profiles?
The reason I prefer that, again, both are valid solutions. The question is, why did I create user ID as a foreign key into user accounts.id? Why did I choose this design? Well, this makes my ID of my user profiles independent of my user accounts table. So this, whatever this ID is only useful to this profiles table. It does not need to match anything in my user accounts. User ID, on the other hand, is the one that needs to match with my user accounts. So this kind of frees up my user profiles ID to be whatever I need it to be. It's only internal to this. My primary key should not matter for any other table in this case.
I guess my question is, why even bother? Like, why would you want to separate that? Why would you want the uniqueness between the ID and user ID under user profiles? Like, if they're both unique, the ID and user ID.
Are you saying why isn't this information in one table?
No, I'm saying like under user profiles, if the ID and user ID are both going to be unique regardless, like why would you not want to tie ID up? Like why leave ID on its own for in that table by itself without any reference?
Because again, the ID is usually not exposed to the user. This is just internal for our purposes to keep our records unique here. Again, both are valid solutions. So I know we usually don't want to see two different ways to do the same thing, but yes, you can make the primary key of user profiles a foreign key to user accounts, and that's going to keep both of these in lockstep. So if I have a user account with ID, 1200, my user profile for that user is going to be 1200. That cannot change. They both have to be the same ID, primary keys in both tables. This lets me kind of allow my user profile IDs to not match my user accounts. Now, I don't know a good use case for that, but it's kind of more flexible, I would say.
So you basically just want to hide the ID from user profiles. They'll be exposed to user ID, but they won't ever see the ID. Is that basically
Correct.
what you're trying to say?
Correct.
Okay, got it.
Again, yeah, I feel like this is not a great reason to have it that way, but it is generally what I go with. I don't like tying my primary key to a foreign key together. I'd rather have a separate field that's a foreign key. My primary key kind of gets left alone. Phil?
Yeah, I guess if you had the IDs directly linked without or not independently,
Yep.
Would you run into issues? I guess does SQL have a way of managing if you like say deleted a user account and then being able to know that that number is now not being used and cycle that number back in, or do you have to manage that directly? Or
Good question.
Is that where the issue comes in with directly tying those IDs together?
I don't think it would be an issue. There's a SQL way to do it. The magic word here is cascade. So we're going to see this keyword at some point, but if you want to Google it, cascade says if a record gets deleted from a main table and something's referencing it, well, that reference will also get deleted. So that connection will kind of be broken. If I delete this table, this connection goes away, and now this table is kind of left on its own. But yeah, you got to use the keyword cascade. Again, there's other constraints you'd add. You could add, don't allow the deletion. So if I were trying to delete this table, I didn't want to automatically have it cascade. I could have that check built in. So if I try to delete this, I'll get an error saying, hey, there's something referencing you. We're not going to let you delete this record. So that you have control over how you want that handled. If you want it to be automatic, or you want it to prevent deleting records that are referenced from other tables. Okay, so we were talking about foreign keys. So we talked about all this stuff. So we have a foreign key between user and post. Again, in this case, the direction does matter. Your foreign key must exist in the post table because that is what's referring to a record in the users table. You will not add a foreign key to the users table and point to the post table in this case. That's reversing the relationship. If you did that, that would say one post can have multiple users as the author for it, which is not what we want. We want one user to be able to create many different posts, but one post can have only one user as the author. All right, and then we have one more situation, and I think this is where I need to create one more table. But let's do comments and posts first, since we have these four tables. What's the relationship between comments and posts? Well, we ask the same questions. Can a post have multiple comments? What do you think?
Yes.
Yep.
Yeah.
So a post can have multiple comments. Can a comment be applied to multiple posts?
No.
No.
Should it?
Yeah, the way Facebook works, you can't really, do that. So yeah, in this case, it's another one-to-many. So in this case, I'll take post ID and refer back to the ID in the post. So again, this is a one-to-many that we have here. So I get these lines not to intersect. But yeah, so that's a one-to-many relationship we have here. But then also we can think about commenter ID. Can one user make multiple comments on the same
Yes.
post? The answer is yes. Can one comment have multiple commenters or authors?
No.
Yep. So this is another one-to-many. That doesn't let me draw it. All right. So these kind of get complicated with all these lines intersecting, but all right. So that's what our comment table will look like. We're gonna have multiple foreign keys. One foreign key for post ID that references my post table, and then one foreign key, another foreign key for commenter ID that refers to my user accounts. Content is not any sort of relationship. That's just unique data to this table. My primary key, again, just a unique identifier for this table. The new thing I'm going to add in here is the concept of a reaction. So if you're familiar with Facebook, you can add a reaction to a post. Like you could like a comment, thumbs up. You could, laugh at a comment. You could be angry at a comment. There's a few different reactions you'd have. So I'm going to say ID is going to be my primary key. And then I'm going to have the reaction type. So the type's going to be like, angry, funny, sad, whatever different types Facebook has. That's going to be, let's just describe that with a varchar. It's probably an icon behind the scenes. There's an icon shown. So maybe you have an icon that's a URL. I'm not sure what it's going to be. Well, let's say there's an icon associated with that reaction. So again, if you like something, you see a thumbs up on a post. That's what you put on there. So we have an idea of a reaction. And let's only make reactions for posts right now because I don't want to get too involved here. Let's say we want to have the ability to react to a post. So now we have a new entity called reaction, and we have our existing, that should be plural, we have our existing entity posts. Now my question to you is, what's the relationship here? So if I go back to my slides, what's the relationship between posts and reactions? We're going to ask the two same questions between these two entities. Can a single post have more than one reaction applied to it? Meaning, if I write a post like, hey, this is what I had for dinner, can both Phil and Lyman react to that post? Or is it limited to only one person reacting to that post? So can a single post have more than one reaction applied to it?
Yes.
Answer is yes. Yeah. Like, let's say Phil can thumbs up my post, and let's say Lyman finds it funny. So he could add his own reaction. There can be multiple reactions to a single post. Now the question is, can a single reaction type be applied for more than one post? Meaning, can Lyman like my post, and can Lyman also like a different post? Can we use the same reaction type across multiple posts? The answer is yes. There's no limitation like that in Facebook. You can use the same reaction for many different posts, and one post can have many different reactions to it. So in this case, we have a yes on both sides. And this is an example of our many-to-many relationship. So again, one post can have many different reactions, and one reaction can be applied to many different posts. Actually, one reaction type. I'm not saying the same reaction, but the same reaction type. All right, so this is our many-to-many, and this is where it gets a little more complicated. We cannot just achieve this with a foreign key. And let's kind of talk about that. So if I wanted to try to solve this, well, the question is, well, okay, I have two tables here. What if I made a foreign key from, let's see, a foreign key from, let's add a new field here, just for example. Let's add post ID as a field here. And let's say that's going to be a foreign key into posts. Well, let's think about this now. We established a foreign key. We've used those before. So now we're saying, all right, we have a post ID for our reaction, and we're going to tie that to various posts. Now, does this achieve what we want it to do? Well, no, because this is going to either result in duplicate data or basically having one reaction ever being tied to a single post. So we're thinking about what our table will look like here. Let's say Lyman wanted to like my post, and also Phil wanted to like my post. How would we store that data? Well, one option would be we'd create a record in reaction saying ID1, type like icon, whatever the icon is, post ID 7. Let's say my post was 7. And then we'd have another reaction, maybe like a user ID that we need here. So obviously users are making this reaction. So the question is, would this work for our needs? So now we have post ID, user ID. Well, this can work, but the problem here is we're getting duplicate data, meaning, let's say, again, Lyman liked my post. We're going to have like, the icon, the post he liked, and his user ID that ties back to here. All right, so this can work. And let's say Phil wanted to like my post also. Well, then now we need a new record in this table that says ID, which is, let's say, ID2. Type is still like. Icon is whatever the icon is. Post ID, user ID. Now this achieves what we want, but now we're duplicating the icon. The icon should never be different for the same reaction type. So this is a very minor example, but we're getting duplicate data when we should not have that. It's not proper design. So this design is not going to work for our needs in terms of having a proper schema design here. Right? So we don't want to just have foreign keys in this table. So let's get rid of those. What if we did it the reverse way? What if we had like a reaction ID here and a user ID? Let's call it reactor ID. Right, so we're kind of putting foreign keys in the other table. So I'm going to tie that to here, and reactor ID will be some user. Well, I'm assuming most of you guys see the problem here. Well, now this is saying a post can have at most one reaction ID and one reactor. So only one person can react to your post with the design. Or we're going to need to duplicate data, right? I write a post and I have content of whatever. We need duplicate records that have multiple reactions tied to that post. Again, duplicate data, not what we want with this design. So again, we cannot achieve what we want between these two tables by just using foreign keys, because we have a many, which means both sides need the ability to have a many. In this case, we're limiting it to one on this side or one on this side. Any questions about why this is not achievable via foreign keys? All right, so the answer here is we can't just use foreign keys. We need to actually create a new table, which we refer to as the join table or the through table, which is going to connect both of these together. So now I need to, again, this is not optional for our needs. We need to create a new table. I'm going to call it post reactions. Again, the naming is up to you, but usually want to marry two tables together, use both table names. This is going to have a unique identifier just like any other table. But the additional things are, running out of space here, we're going to have a post ID. We're going to have a reaction ID. So again, what type of reaction? Is it a like? Is it a laughter? Is it a sad reaction? We're going to have a user ID, or we call that reactor ID. All right, so now we have a brand new table here, and this is basically going to marry these two concepts together, or the relationship, so that we could have the many to many. So let's hook up all the wires. Post ID is going to refer to our primary key and posts. Reaction ID is going to refer to our reaction primary key, and user ID, the person making the reaction, is going to refer to, let's put this in the middle here. So it's getting kind of unwieldy. All right, so a lot of crisscrossing lines. Hopefully you guys can follow all the madness here. But now we have post reactions, which kind of sits between our reactions, posts, and user accounts, because it's combining all three concepts into one record here. So this join table is necessary for a many-to-many relationship. And this allows us to have, we can have the same post ID and multiple reaction user IDs. So again, I as a user, let's say I write a post. So my post is, I had macaroni and cheese for dinner. Lyman can react to it. Sorry. Lyman can react to it. So we'd have a record for Lyman in here, which refers to his user ID and whatever reaction type he provided. So let's say he liked my post. Well, that reaction ID will refer to the like type in my reaction table. His user ID will be referenced because Lyman's the one making the,
I do like macaroni and cheese, so this is a true statement.
Sorry, this is zooming way weirdly. So sorry for that Zoom chaos. So that'd be one record in our post reaction table. Let's say Phil wants to laugh at my post. So we'll have a new record in our post reactions table that says what type of reaction is this? This is a laughter reaction. So whatever the ID for that laughter reaction is, his user ID will be tied here and it will refer back to my same post. So in this way, the post ID can be duplicated with different reaction and user IDs. Likewise, let's say Philip is going on a liking rampage. He can like multiple different posts with the same reaction ID and he'll have the same user ID here. So in this way, we are not duplicating data. In this case, my icon that I'm referencing is only in one place. I don't have to recreate that from multiple records. Same thing with user accounts. I don't need to recreate, all the information in my users table to kind of have this concept at play here. Jesse, you have a question?
Yeah, more of a clarification to make sure I'm understanding it. So a join table is basically taking the IDs from tables that you're going to utilize and putting it into a foreign key into that join table.
Yep, absolutely.
Okay.
Yep. So all of these are going to be foreign keys pointing to other tables. It's kind of uniting them into one record in our post reactions table. Okay.
So if you had I guess you say the reaction in this case would be like the thumbs up like symbol. You don't want to duplicate that. And that's why you're creating that's the primary reason why you're creating the post reactions table.
Yeah.
To
So
avoid duplicating the same reaction.
Yeah, this is very minimal data. Our data right now is just this type identifier. So like, and the icon will be thumbs up. Imagine there's a lot more data here. We don't want to recreate that data each time a reaction is made. That reaction has static data and we refer to it as many times as we need to.
And then my second observation is post reactions very similar to enrollments in the previous example. Is that kind of what enrollments was doing?
Yep. Enrollments was
Okay.
combining the idea of courses and students, because one course can have many students and one student can be in many courses. So yes, enrollments in that case was our join table. Again, the naming is up to you. I usually, again, just use the two tables I'm combining. So in this case, post reactions. I guess user tables in the mix also. But yeah, so that enrollments was our join table in that case. We just didn't tell you it was a join table. Okay, so here's what I'm going to suggest. We're approaching lunchtime. There is more content I'm going to go through and I don't want to rush it. So I'm going to break over here. So we have our design created. So that's a thumbs up for us. We could add a like to our design. So we have the design that we want. We want to convert this to SQL. So again, this is just pseudocode. This is nothing related to SQL. We want to take our design now and convert it to SQL. So after lunchtime, let's continue our lecture, understand how we actually create foreign keys or unique keys or primary keys, and we'll see how that comes together. One last thing before we break for lunch, there's one issue with the design. I want to see if people can identify it, knowing how Facebook works. The issue is with my post reactions table. Again, this is different on Slack than on Facebook, in my understanding.
Isn't there usually, like if you click on the post reactions, they do a list of all the users for when they're looking at the post?
Yeah. So that is more on the front end. So if you want to see like which users reacted to your post or what type of reactions, yeah, you can achieve that on your front end. That would not change our database sign here. But the one thing that is different between Slack,
Liking comments,
what was it?
so you can like comments.
You could like comments. I actually purposely left that out here because that's going to require another join table here or some more complexities. But you're right. We can like comments.
Sorry.
Only have I think on Facebook you can only have one type of reaction per post.
That is correct. Yep. So on Slack, we're familiar with Slack. You use that internally. You can react to the same message with multiple reactions on Slack. On Facebook, however, you cannot both like a post and say react that a post is funny. You're limited to one reaction per user per post. So the issue here is this design right now allows us to, I could add a reaction that's like, laughter to post 7. I could also add a, sad face to post 7 with the design here. So this isn't a complete solution. What the actual answer is, we need to make a unique key between user ID and post ID. That needs to be a unique combination within our post reactions, meaning you can never have a user ID. You can never have multiple user IDs that are associated with the same post ID in this table. So again, this gets a little complicated using, again, unique keys and primary keys and foreign keys. We'll see the solution on the other side of lunch break. But just kind of understand that this is how you create proper schema designs. You need to think about what relationships you want to maintain and establish. And that's how you go about adding constraints, whether it be a foreign key, unique key, primary key, creating join tables. That's all the work you need to do to create a proper schema design. Jesse?
Just real quick, so my understanding, the unique key is really dealing with the table within itself.
Yes.
Okay,
Yep, it guarantees that whatever combination, either one single column or a combination, right? We mentioned keys can span multiple columns. So in this case, we want to create a unique key with post ID plus user ID in conjunction. Because you could have the same post ID listed in this table, that's fine. You could have the same user ID listed in this table, but you should never have the same post ID and user ID in tandem in this table. Otherwise, that means the same user can react to the same post multiple times, which is not what we want for our design. So again, all these questions we need to ask as a database designer to make sure we design our database correctly. Okay, so a lot to digest there. I know we still are probably unfamiliar on how to achieve this with SQL, but we'll see that after lunch. I don't want to eat into your lunchtime right now. But before we break and take that lunch break, any general questions about constraints? So again, primary keys, foreign keys, unique keys, understand what they are achieving, and also relationships, one-to-one, one-to-many, many-to-many, and we'll see how we implement them. Kat?
Yeah, I'm sorry. If I don't want to eat until lunchtime or anything, but for the post reactions, that's like, is it creating this for every user that likes it, or like I'm wondering, is user ID like an array of people who liked it?
Nope, no arrays here. I know Jake and Jack mentioned you can have array data types. We will not work. We will not be using array data types in our course. So the question is, I write a post. Let's say Kat likes my post. There'll be a new record added to post reaction with Kat's user ID, whatever she reacted with, and tied to my post that I created. Now, if Kat finds, let's say Tanner wrote a post and Kat wants to like that post, a new record will be added with Kat's user ID again, but now the reaction ID may or may not be different. If she liked it, great, it'll be the same. But the post ID will now refer to Tanner's post, not my post. So it'll be two separate records if Kat liked two different posts.
But your post gets, I'm sorry, your post gets a post reactions table for every single user that likes it?
Yes. Every user that I guess creates a reaction to any post, we'll have a new record in our table here. But we're not duplicating any like username password data that is one time only. Like Kat, you have one record in this table, but you might have multiple user IDs that refer to your account because you might make 20 different likes on different posts. Okay, I feel like there's probably still some confusion here, so let's take some time over lunch to digest that, and then we'll come back and revisit this example after lunch. Sound good? All right, so we have created our data model, a good kind of visual here of what our tables look like and what relationships they have with all these lines kind of intersecting. Kind of gets hard to follow, but hopefully we kind of understand what these lines represent. Again, the tick marks do matter. So a single tick means a one-sided relationship. The crow's feet means that's a many-side. So we might have a one-to-one, like between user accounts, user profiles. More commonly, we'll have one-to-many in this case. So with post reactions, user accounts, posts, and reactions, all have a one-to-many relationship with post reactions. You could have a many-to-many, which is what the post reactions has between posts and reactions and user accounts. We talked about that before the break, but if there are any questions about one-to-one, one-to-many, many-to-many, please ask your questions now.
Hi, Anchor. I had a quick question. So I noticed that under user accounts, ID is linked to multiple, I guess, items, but no other item is linking multiple times aside from the ID under user accounts. Is that good practice?
So no, I mean, you're
Is
gonna.
that what you're supposed to?
Oh, sorry. Yeah, you're gonna have many wires here. Again, this is a subset of all the connections we might have. So user accounts is a popular one because that is the main, as a user, like my actions I do kind of relate to everything, whether it be posts, comments, reactions, whatever. That's always tied to some user doing that. So that's why we have multiple things referring to the same table here. But yes, user accounts has multiple foreign keys pointing to it, but that's not uncommon. In this case, it seems to be the only one that has multiple references, but there's no design reason why that needs to be the case. What else? Any other questions? Elon?
Thank you. Just wondering if it's possible to give an example for the unique key, because I find myself still a little confusing about it.
Yeah, absolutely. Let's actually get into writing SQL. We've avoided doing that thus far, but let's actually take this data model and convert it to a schema file so that we could actually apply it to our database. And then, yeah, we'll try to see a unique key why we need it. We'll see it in a couple cases. We'll see it in user profiles and also in post reactions. So we get a double dose of unique keys.
Thank you.
So for this, I'm going to go to my VS Code and start writing a schema file. So I'm just going to name it schema.sql for lack of a better name. All right, I'm going to create a database for my usage. Let's do create DB Facebook DB. All right, so that's the name of my database. Cool. So no errors means that database got created. Now I'm going to try to save some time by copying some code on here. But let's create our initial tables. All right, this is just our tables, no relationships. All right, so first we want our user accounts. So I pasted in what our user account table might look like. Again, hopefully nothing too surprising. We have a primary key field. We have a username, password, bar chart 64. Let's leave out the not nulls for now. We'll deal with those later. But okay, so we have our fields, we have our data types, nothing too exciting there. If anything surprises us, please ask freely. I'm going to create our user profiles. Again, so I'm just creating the tables right now, no relationships. This is step 2 of our schema design. We thought about our design. That was step 1. If we go back to our designs. Yep, we just did the thinking part. That was our step 1. It took a while, but again, sometimes it does take some time. Step 2 is creating our entities. So that's what we're doing right now with our SQL. So we're going to be creating our tables, which are entities in our database. So let's do posts. Again, I'm just copying and pasting to expedite things. So our post is going to have an ID, author ID is what I called it, and content. We're going to have some comments, so comment entity. More space here. We have comments. That's what our comment structure might look like. Again, we have a post ID. So comment is always tied to a post some manner. There's going to be someone writing the comment, and the content is what they actually write. We're going to have a reactions table, which is just storing kind of like the hard-coded reaction types that we can have. So again, this might be like, funny, sad, whatever reactions might exist. So I missed a line. All right, so fair number of tables. The last one that we talked about is that join table. So that join table is going to look something like this. We'll call it post reactions, our join table. And we're going to have an ID. So each record is going to have a unique ID, just like always. We're going to have a post ID, reaction ID, and a user ID making the reaction, all tied into one record. All right, so hopefully nothing too surprising going on here, no tricks here, just straight up creating our tables with our appropriate data types and the field names that we want. Any questions here? Oops, that should not be there. All right, I think we're good. All right, so I'm going to run the schema file and just create these tables in my database. So to do that, I'm going to run psql Facebook DB, feed it my schema file, so schema.sql, that's what I called it. Hopefully I have no typos, but that's never a given. Okay, so notice I got 6 create tables statements because I've created 6 tables. Now again, if I try to run this again, I'll get an error because all of these tables exist. So if I wanted to, I could add some drop table if it exists. And I'll say user accounts. Let's do all of them at the top. profiles. And there's a reason I'm doing this because I want to talk about the cascade keyword that we mentioned briefly before. Posts, what else we have? Comments, reactions, and post reactions. I'm purposely not doing comment reaction right now. That is a little more involved to talk about. All right, so we have our tables. We want to drop them, that's fine. We should be able to run our schema as many times as we want now. Oops, that's not user. Let's try that again. Okay, cool. Relation comments. Done that. Made that poorly. Let's just drop my database. We'll start from scratch. Drop DB, Facebook DB, create DB, Facebook DB, and then run my schema file on that. All right, there we go. That looks good. All right, so we have our tables created. Now the question is, well, are we good to go now? Like, can we just start creating some data? So I'm going to create a new file called data.sql. This is the data I'm going to insert into my database here. So again, same thing as before. In interest of time, I'm going to create some records. We're going to use our lovely and helpful TAs to kind of seed our database here. So we'll say user accounts. That's not what I want. Copy and paste. So we have 4 users in our Facebook system. We have Andrew, Rebecca, Tanner, and Terry. They have their login email, their password, and their last login date is something that we're going to record also. So let's say Andrew's never logged in before. Rebecca, Tanner, and Terry have logged in recently. All right, so this will fill our user accounts table. Okay, so if you want to give that a run, I can do that by psql, Facebook, database, and feed it to data file. So data.sql will run these 4 commands. It's going to insert 4 records into my user accounts table, assuming I don't have any typos here. Okay, notice I got 4, which means inserted 4 records with this one command. You know, we could do a simple, let's do queries. So queries.sql. Let's do a simple select star from user accounts. Nothing exciting going on here. Just make sure our data got into our table. So I'm going to run queries, which is going to run this command to show us all the user accounts. And there we go. So this is the data in our database. We got Andrew, Rebecca, Tanner, Terry, their password, and the last login date. Okay, nothing too exciting there. But what if we move on to inserting some values for our profile? So as we talked about, each user can have 1 profile on Facebook. So let's create a user profile. And let's just insert some data. So this is data. I'm highlighting that here, the IDs don't need to match up with any IDs here. It is the foreign key on user ID that needs to match. So that's why I've given some random IDs here, just to highlight that. Hopefully that's not too confusing, but these are the primary keys for this table. The second values here are the user IDs that are being referred to in the user accounts table. Now, if I run this, let me comment this out because I don't want to duplicate the data. Let's run my data file. So it's going to insert user profiles into my database. All right. So I run that. Notice I got 4 records. We can do a select statement, but these got inserted in. Now the question is, why is our design not complete with our schema? Well, there's a few things going on here. These reference users that exist, but what if I want to insert a new record? I do insert into user profiles. Let's just copy this. What if I want to enter a new user? Let's say this user has ID 99, or this profile has ID 99. I'm referencing user ID 5. Is there anything stopping me right now to enter this in? So this is, again, a new profile that I'm creating in my system. It's saying this is for user with ID 5. Notice that user does not exist in our accounts table. What is this? Photo, no one has a profile photo. They have a personal quote. Now, is there anything stopping me from doing this? Well, let's find out. Let's just run this. So if I run my new command, that is syntax error. I wanted. Notice that this got inserted into my system, but this is problematic. This is saying some user account 5 exists, but it really doesn't. So this is where foreign keys come into play. We have no relationship between user profiles and user accounts right now. We're just kind of saying they're independent tables and they do whatever they want, even though we want it to reference the user accounts. There's no magic way that SQL just knows, hey, okay, you have user ID here. I assume that you just want to link to your user accounts. SQL is not that smart. So we need to tell SQL that we want this field to be a user, to be a foreign key. So I'm going to drop all my values here. Delete from user profiles. It's at a where clause. We don't add a where clause, everything gets deleted. Let's say where user ID equals 5. So I want to remove this record that I just inserted. So that should be pretty simple. Semicolon. All right, run that. So we deleted one record. This new user should no longer be in our system. But now let's go to our schema file. And now let's say, well, okay, so we talked about that these two tables want to relate to each other, but right now they have no relationship. So the answer here is we want a foreign key for this field that's going to point or refer to the ID, the primary key in the user accounts table. There are two ways to do this. There's the shorthand way where we could do it inline. We could add a references. And then the table we are referring to, in this case, it's user accounts. And then the field that we want to refer to. All right, so again, the syntax takes a little while to get used to, but here we're saying this user ID field is an integer, but it's going to refer to the ID field in my user accounts. So now for this to have a valid value, it must match something in my user accounts table. All right, so again, this is kind of the short, quick way to do it. I'll show you another way to do it in a second. But since I made a change to my schema, well, now I need to run my schema file again. So it's going to kind of drop everything and recreate everything. Not a big deal right now. I'll live with it. So I'm going to go with that approach for now. So let's run my schema file. I think I could just do that. Facebook schema .sql. Will this work? Facebook DB. Okay, there we go. So it dropped all my tables, including all the data in them, and then it recreated my tables. The reason is because my schema changed here. My field is no longer the same as it was before, but now I have this new references. So this is a foreign key, just to highlight it. All right, so this is a foreign key I've established. Now the difference is if I go back to my data, let's reinsert our data since we deleted all of it. We're going to insert our users, our profiles, and the question is, can we insert a new user after that? So let's do the basic thing that we did before. I'm going to run these two inserts, using my data file. Okay, so we inserted 4 user accounts and 4 profiles. What if I want to insert this record? Let me create a new file, maybe so I don't have to comment as much. Let's say mod.sql. All right, so these are additional things I want to do. So now we want to insert a new user. So I'm going to run my mod file. And now we're saying, all right, user profiles is going to get a new profile that points to user 5, which does not exist. Previously, we were able to do it with no problems. And that was our previous design. What if we run our mod.sql now? What's going to happen? Notice we get an error, and this is an error we want. Like, we should never be inserting a profile that refers to a user account that doesn't exist. So notice it gives us a nice descriptive message. This insert failed because the foreign key constraint that we added was violated. Notice user ID 5 is not present in user account. So very descriptive. This is exactly what we expect, and this is what we want for our design. We don't want, again, a profile that refers to absent accounts. Porfi, question?
Yeah, I just wanted to make sure. So the references was the syntax that made that happen, right?
Yep. So this additional line saying this references is basically adding a foreign key behind the scenes, and that we're specifying we're looking in the user accounts table and matching the ID field. So we're saying this user ID must match this ID in this other table.
Gotcha.
If it doesn't, we'll get an error like this. So that is a foreign key at play where we're saying, hey, this must exist, like a record must exist in user accounts for us to refer to it. Shun, you have a question?
Yeah, so when we talked about earlier on, if we just wanted the IDs the same for the user accounts and user profiles, it's just the same thing, just putting that references instead of the user ID to the ID.
Yep, pretty sure this would be valid syntax. Might need to look that up, but yeah, you can make the primary key a foreign key. I don't see that as often, to be honest. I'm not a database administrator, so I don't create databases very often. But yes, you could create your primary key that explicitly is a foreign key to another table. That is totally valid. We had some hands raised. Bill?
Yeah, I just want to make sure I understood. So right now there's no limitations on which user ID it can reference. It can reference one over and over again.
Yes.
Right.
So that is the
Okay.
second part. I'm glad you brought that up. So this is a foreign key. This is establishing a one-to-many relationship. However, as we discussed with our diagram, or creating it, we don't want multiple profiles for one user. Facebook does not allow that, as far as I know. So our design is not fully complete. We can still create more records. Let's go to our mod. Let's say, I forget, I think 4 was Terry. Let's say Terry's going to create a brand new profile. So she's going to say, this is Terry's other profile. This should not be allowed according to Facebook's design. We should not let Terry ID 4, if you guys remember from our data. So Terry was ID 4. She recreated a profile right here. Now we try to create a new profile. Is there anything stopping us is the question. So I'm going to run mod.sql. Notice this got inserted. Well, great. Terry has 2 profiles on Facebook now. That's probably not going to make Facebook very happy because that's not what they intend. So that is the second question here. Well, we established a one-to-many relationship with our schema with a foreign key. That's what a foreign key does. It does a one-to-many. We want this to be unique also. So there are a couple or maybe more than a couple ways to establish a unique relationship. The easiest way in Postgres, you can just add the unique keyword here without mistyping it though. If you add unique here, that adds a unique constraint or a unique key, meaning this can never be duplicated. Now, again, I'm going to have to rerun my schema, and it's probably the last time I'm going to try to rerun my schema, or at least for the time being. So let me rerun my schema. There's my schema. User accounts. Did I not delete it correctly? Sorry. Error with user accounts. Oh, right. Cascade is what I'm going to talk about. Sorry, we're going to take that again. Yeah, that works. Magic word cascade. I'm going to talk about that in a second. I know there's a lot to cover here. But right now we have foreign key, and now we added a unique key. So let's try this. We ran the schema. Let's try running our data file and our mod file. Let's just do both together. So let's try, we're going to create our main profiles and try to let Terry create another one. Let's see if this works now. Clear this, run our data file. So again, we're going to create our users. We're going to create our profiles for each user and try to let Terry create one more with this second insert statement. All right, notice we get an error. That's what we expect. Now this says duplicate key violates unique constraints. Unique or ID 4 already exists in this table. So this is how we achieve that one-to-one relationship, where we have a foreign key plus a unique key makes this a one-to-one relationship. We can never have more than one value for user ID in this table. And that's what we want. So that's how we achieved our one-to-one relationship. Again, we added a foreign key. If we go to our schema, foreign key is this bit right here. The unique key is this bit right here. Now this is, again, some shorthand. There's different syntax to achieve the same thing. The one problem with what I've been doing, if you guys noticed, is every time I modified my schema, I need to rerun my schema and basically drop tables and recreate them. That's not ideal. Again, you should not be dropping your tables and recreating them because you lose data. Not the way we want to go here. So this is where you should be using the alter table command. So alterations, you create your tables. After your schema is created, if you need to make modifications, you can use the alter table command. And this has so many iterations to it. We're not going to go through every single one. If you search for alter table Postgres, you can alter column names, column data types, constraints. So again, these are all the alterations you can do. In this case, we want to do alter column. So again, a lot you can do with alter table. We're not going to do all of them, but let's search for alter column, add foreign key. Hopefully this is Postgres. Yeah. So we want to, after we create our tables, we want to add some additional alterations to it. So this prevents us or doesn't require us to drop the table. It just modifies it on the fly. So our data does not have to be dropped. So let's look at some of our other tables here. We established this one-to-one. Let's do user accounts and posts. So there's a foreign key from the post table to user accounts. I don't want to drop all my tables. I want to just modify my existing table. So after I create all my table, I'm going to make my alterations. So here I'm going to have to add a constraint. Yeah, so I want to do alter table. Which table do I want to alter? I want to alter my post table. So I'll say alter table post. Again, the syntax here, you're going to have to look it up because there's a lot to the alter table command. I want to add a constraint. Again, this is one of many alterations you make. You rename columns, change data types, add other constraints, but I got to spell constraint correctly. Add constraint. I'm going to name my constraint. Now this is optional, but usually it's good to have some names. So I'm going to name this post users or authors. Now let's call it users. So basically I'm pointing from the post table to the user accounts table. So I'm going to call this user accounts. That's how I go with my naming. Again, naming can be subjective, but I want to make it descriptive to make it clear that this foreign key is meant to tie my post table to my user accounts table. Then we add foreign key. Foreign key, which field in my post table is going to have the foreign key. In this case, it's author ID is the one that's going to point to my user accounts table. So in my foreign key parentheses, I say author ID is the column getting the new foreign key. And then I'm going to tell it what its references. So references, which table? Well, that's user accounts. Which field? That's the ID. So kind of a lot to write here just to make one minor change, but this is the syntax for altering your table rather than dropping your tables and recreating them with a new schema design. So yes, this is much easier, right? Like kind of in line, but if I want to make a modification to my post table, I don't want to change my schema. I just want to alter it. And this will let me do it without dropping any data that might exist. Questions out there? Shun.
Yeah, so what if you had already inserted an ID before you made it like unique? Does that make sense?
Yep, absolutely. You would get an error.
Okay.
You need to modify your data record before applying that constraint. So we could actually test it out. So I've not run this command yet. So let's actually keep that out of the fray. Let's add some more data. So we did user accounts, user profiles. Let's add some posts. So I have that coded up. All right, so our TAs are going to add some posts to Facebook. So each of them are going to add 2 posts. Andrew's first post, Andrew's second post, Tanner's first post, Terry's first post, so on and so forth. So each of them have a unique post ID, but the second value here is the user who's making the post. We don't have that foreign key set up right now. So technically, there seems to be an error here. I'm not sure why that's red. It's kind of scaring me, but let's add one more made up record here. Let's say our 9th post is going to be made by user 5. Again, this is meant to be a foreign key, right? Author ID should be referring to some user that exists. But right now, we do not have that foreign key in place, right? I've not added that foreign key. So if I run this right now, wish these red parentheses would go away. If I run this right now, this is going to work without any errors. Because again, there's no relationship between posts and my user accounts table. So let's run this. I'm going to comment this out because we don't want duplicate data. So I'm going to run this command. So insert into posts, some posts by our TAs. So run this. All right, so notice 9 records got inserted because I have 9 posts. But the question is, well, what if I want to alter my table schema and now I want to add this foreign key? What's going to happen? Let's find out. It might work. It might yell at us. I'm not sure. So if I run this, let's put this in our mod section. All right, so I want to alter my table. We already have data in there. Let's see what happens when I run this. All right, notice it's going to check immediately if we have a violation. So the question is, did this foreign key get added? Well, we could check pSQL and see if it got added or if it denied us. Let's go into pSQL Facebook DB. I want to check the definition for my post table. All right, notice that the only key on this table right now is the primary key. So my foreign key that I attempted to add got denied because there was a record, at least one record that did not satisfy the foreign key. So the foreign key did not get added to my table. So to resolve this, I must first clean my data records and then apply the foreign key. So if I quit out of this, we could do this with a simple select statement. So let's do this right here. I'm going to say select we'll do an update. Yes, update from posts where, I mean, there's multiple ways we could do this. I'm just going to take the easy way out. I know that user ID 5 is the violating case, or author ID 5. So update from posts, we want to set author ID to be null. Null is valid right now. So I'm going to set it to null instead of 5. Null is valid for foreign keys. So you can have a null value for a foreign key. That is okay. So I think that's correct syntax. Hopefully I'm remembering this correctly. So update from post. Let me double check because make sure. So update set Postgres. Always good to read documentation. Updates. Update table set column equal. Yeah, okay. So I don't need the from, that fits some other place. So we're going to update the post table. We're going to set the author ID to null where the author ID is 5. Because 5 is the made up value I did. Let's try running this. Okay, so notice I was able to update my table. So I cleared the violating record and made it null instead of 5. And then I applied my foreign key. So now I'm good to go. So if I go back into pSQL, Facebook DB, investigate my post table, notice I have a new constraint, a foreign key constraint that I just added. This is the name I gave it. Naming can be whatever you want it to be. It's telling me that now the author ID column references my user account's ID column. And so again, alter table is the better way to do it because I did not need to drop my tables and recreate my tables and add my data back in. All I need to do was update my violating rows if I had any, and then add the foreign key in later. So this should be the preferred way to do it because you don't want to take down your tables all the time. Questions about alter table here? Again, this is going to require reading documentation. Porfi, I see you're shaking your head. Is that no questions or you're totally lost?
No, I'm not lost. Just saying no questions. It's
Okay.
a lot though. It's a lot for sure.
Gotcha. Okay. Want to make sure I wasn't losing you there. All right. So again, we added another foreign key. So we established this relationship. So this line over here that I'm kind of hovering over, that's our foreign key that we established. And that's a one-to-many. So in this case, we do not need a unique key because, again, one user can make as many posts as they want. And that's fine. We have multiple author IDs across different records. That's going to be fine. So that's checked off. Again, a lot of relationships to create. We did this one. We did these 2 tables. We can do the comments and posts. So let's do that quickly. So comment table is going to have 2 foreign keys. One is the post ID pointing to the post table. Commenter ID should point to the user accounts table. So again, just to get more practice here, let's alter some more tables. So go to mod. Let's comment this out. I'm going to copy this. Okay, so we want to add another constraint, this time going to the comments table. So the comments table, we're going to create a comment posts. I don't know if I should make that plural. I think I renamed, I should probably made that posts. All right, so we're creating a new foreign key. In this case, the commenter ID from the comments table should, or sorry, this should be post ID. The post ID within that comment table record should point to posts and ID. And then likewise, we're going to have comments users. And then the commenter ID as the field name that we gave it should point to the user accounts ID. All right, so just creating more foreign keys. These are the two wires right here, this wire right here, we're creating, and this wire right here. So we're almost done. The last one is going to be post reactions, which has a lot of wires going in and out of it. But we're going to create these two for our comments table. Let's see if this works. If I'm going too quickly, again, if there's any questions, please stop me. I'm going to run mod.sql. There we go. So alter table happened. So these two foreign keys got added. So this should protect us, again, give us good data integrity, make sure we're not adding in bogus records. What else? All right, last thing we need to do is post reactions. So I'm going to add some more data. Let's comment this out. So we're going to have some hard-coded reactions. These aren't going to change. Like these aren't, you know, users don't add reaction types, but our database still needs a concept of these values to start off with. So we're going to have like, funny, angry, sad, and love as our 5 reaction types. Not going to bother with the icons. So if I go with running my data file, data.sql should enter in 5 reaction types that can be used later on. All right, cool, that works. Now the last question is post reactions. How do we model that? Now, as we talked about, this is a many-to-many relationship, so we can't simply just use foreign keys to accomplish this. We need a brand new table to do this. And I think we already created that in our schema, so we should be good to go. So looking at our schema, we already created our post reactions table. This is our join table, which is basically combining the idea of reactions and posts, and I guess users also, into a single record here. So now we can create a bunch of post reactions. I've not coded this data up, or I guess I've coded one record. But we need to create all of our alter table statements. So let's go to our mod. Again, it gets tedious. This is what database design is all about. I need to add 3 constraints in our post reactions table. I guess I probably should have coded all this up because you don't want me to see me typing it. But let's just say post reactions post. Good time to ask questions right now while I'm typing this up. So what questions do you guys have out there?
How often is it realistic that you're gonna be altering the tables after you make them to be just in foreign keys?
Good question. Not very often. Again, this is where your design, the time you take to design, you should do this kind of in your schema instead of doing it after. But yeah, again, there might, requirements might change. Like, hey, we have a new table or we have a new requirement that you need to alter your existing data. So it could happen, but it's not going to be common that you're going to write these statements very often. Kat, question.
Yeah, I'm sorry. I feel like I'm asking you the same question again,
No,
but
good.
about post reactions. Okay, is every time you make a post, a new post reactions created, or is every reaction ever somehow stored in the same table? Does that make sense?
Let's get to that in a second. So let me write this out. So we have reactions ID, this is the reaction ID, comments. This is the post ID, should have been posts. All right, so a bunch of foreign keys to 3 different tables. So reactions, that's the 3 wires that we're coding up here. So this wire, and this wire, those are all foreign keys. It's a one-to-many relationship. And hopefully we can answer Kat's question once we get these keys in there. So let's run my mod file. Got a lot of hands raised, so. All right, let's run mod. Cool. So we got 3 foreign keys. That's great. Let's take some time for questions here. Phil, question?
So on the add constraint where you add the FK on the front of that, is that just the syntax thing, or are you naming the constraint, or what's going on there?
Yep, that's just the naming convention. It's kind of like naming a variable, want to have some appropriate types. So FK just stands for foreign key. It is optional. You can name this whatever you want. If you don't give it a name, Postgres will automatically generate a name for you. So you'll probably see that if you do it the references way. So we do it the way I did it here, it's going to generate an automatic name for that key. So it's going to have some unique name so that that key can be referred to in whatever capacity you need to.
So that's kind of the equivalent of using the references line once in an alter, and you're assigning it an actual name. Can you then use that name somewhere else for some reason?
The foreign key you could. Usually it's the way I've seen it is mostly like when you get an error, it's going to tell you which foreign key is the one generating the error. So you want to know, again, like our reaction table has 3 foreign keys. If I get an error, I want to know which foreign key was the error. Was it this one, this one, this one? That's why they have names. So just you can identify which of the keys generated the violation. Justice?
Yeah, so I was wondering actually, so we were talking about it earlier before somebody kind of touched on it as well. So if you were gonna alter the tables or maybe add a table to your database for a new feature you're rolling out. So in this case, I was thinking of when Facebook rolled out the reactions instead of just like the like. What would there be anything that you'd have to do with like your database to like prepare that? Or do you just add the table and start linking things and you know?
Yeah, it's more the latter. So if we needed a new table, we just add a new, like do another create table. That won't affect any of our existing tables. We wouldn't need to rerun our entire schema file. We just add a new table, whatever it may be, and then add the wires to the existing table if we need foreign keys. All right, were there any other questions out there? Since I feel like there's probably still some confusion, but
I'd just like to confirm, going on with what Philip said. So with the FK post user counts or whatever, the add constraints, FK, whatever. So that's just to let us, the user, know which foreign key could be causing problems, correct?
Correct. Yep.
But it's not like something that we can use, for example, select column name from whatever, is it?
Yeah, I want to say, you're not going to be selecting things based on a foreign key. I've not seen that. I don't think that's allowed, but maybe Google will correct me. I just want to make this clear. You can leave that name off if you want. Postgres will automatically assign a name if you don't provide it a name. But I like naming my keys if I'm creating them, so that is why I'm going with that. Sanjaya?
So for a 1:1 relationship, we use a foreign key and a unique key, right?
Correct.
So can we just do that for one of the tables, like randomly? Can we choose one of the tables to apply the foreign key and the unique key, or do we apply on both of the tables?
So if you want to establish a 1-to-1 relationship, you need a unique key and a foreign key on one side of the relationship. Again, I don't need it on both sides. So in this case, user accounts and user profiles have a 1-to-1 relationship. Notice I only have the unique and the foreign key on one side of the table or the relationship. So only user profiles is specifying a unique key and a foreign key pointing back to user accounts. User accounts does not need to do the same in reverse.
Okay, thank you.
Okay, there's one problem though, as we highlighted at the very end of our lecture before lunch. As it is right now, there's nothing stopping me. So let's actually add some data so we can see this. So here's my post reactions. Notice it's just a bunch of IDs, right? The first ID is the unique identifier for the post reaction. And Kat, I want to make sure we answer your question here. Second one is which post are we reacting to? So if we look at our data, I know it's kind of a lot to look into. But these are the posts that were made. So Andrew's post is ID number 1. So we're reacting to Andrew's post, that's ID 1 right here. The reaction ID is type 2. So whoever is making this reaction is reacting with a funny reaction. So that's what ID 2 refers to. Again, these are all foreign keys we set up. And then 4 is user 4 is the one making this reaction. So that is, looks like Terry is reacting to Andrew's first post with a funny reaction. So yes, this will be a record in that table. Now let's say we want to add another record. Let's say Andrew's post is attracting a lot of A lot of buzz. So we'll have a new unique ID. Andrew's post is ID 1 still. Let's say someone's angry at Andrew's post, and that's going to be Tanner. I don't know why Tanner's angry at this post, but Tanner's ID is 3. This 3 refers to angry for the reaction ID. So now we have 2 different reactions, which means 2 different records in our post reactions table. Kat, I know you had a question related to this. Now you were asking about posts or reactions, or can you re-ask your question if you don't mind?
I think this explains, yeah. So like every reaction ever is stored in here. And if it's something like Facebook, this table would be like huge, right?
Exactly. Yeah. So the reason why we have this join table is, let me highlight this with a few more reactions. So let's say post number 2, which is Rebecca's first post. Let's say that gets some buzz. So 1 and 1. Again, I know it's kind of hard to parse this data because we're kind of just referring to other tables, but let's do it. Sure, let's do it this way. So notice what values we can have in this table. Notice that the post ID can be repeated. This is totally valid. The user ID can be repeated. Notice Terry is in here twice. She reacted to this post and this post. This is what a join table allows. You can duplicate, various records in this table. This would not be achievable if you had a foreign key on only one side. That would kind of limit you to having a one-to-many as opposed to many-to-many. So the many-to-many here is one user, Terry, can react to multiple posts. One post can have many reactions, right? Andrew's post has 2 different reactions from 2 different users. That is the many-to-many that we established here. Now there's one issue with this. We talked about this right before lunch. What if, oops, this should be 4, not bad. This should be reaction 5. Let's say Rebecca's post, which is post 2. Should Terry be allowed to both like Rebecca's post and also be angry at Rebecca's post? So currently there's nothing preventing this. If I ran this with our design right now, Terry has the ability to react to Rebecca's same post with 2 different reactions, which is not what Facebook should allow, but that's what our design has allowed right now. So if I run this, let's just insert this data to see what's going on. All right, so I'm gonna read my data file. Hopefully I don't have any typos here. All right, so we inserted 5 records, but this is not what we want to allow, right? Terry, ID 4, should not be allowed to reply to the same post here. So this is another example why a unique constraint would be beneficial. So if I go to my mod, we altered a table to add foreign keys, but you can modify a lot of different things. So we do alter table, add constraints. Let's call this UQ post reactions post users. We want to make that tandem be unique. All right, so we're going to specify our post ID in conjunction with our user ID is going to be unique. So together, that combination should only exist should ever exist once in our post reactions table. References. No, I don't think we need references. References is for foreign keys. So I believe this should take care of it. We're saying we're adding a new constraint, and that's going to be a unique constraint that ties these 2 into some unique relationship. So again, we should never have post ID plus user ID repeated in our reactions table. Now, hopefully I got my syntax correct. Again, a lot of this requires a lot of looking up documentation. Let's see if I got this correct. So if I run this, it should get an error because we have a violating record. Well, let's try running our mod file. We need a table, of course. That is my fault. Can't just add a random constraint to some imaginary table. There we go. So notice that we got an error. Post ID 2 with user ID 4 has been duplicated, which makes sense because we inserted, again, post ID 2 with user ID 4, which is Terry, twice. So again, this constraint cannot be added right now. We need to clean up our data, so we should be able to, again, I'm just going to be lazy. I'm going to say delete from post reactions where ID equals 5. I'm going to remove the 5th reaction. Again, you can make these queries more complicated if you like actually want to know all the records that violate it and you don't know the ID that does it. You can write a query for it. I'm not going to get that involved right now. But if I run this, all right, cool. So we dropped the violating record and now we added a constraint. So now if you try to run data again, if I tried to insert this new data, I should get an error because it's going to violate my unique constraint. So run data. Yep, that's exactly what I want. It's saying, all right, you already have a record that has post ID plus user ID of 2 and 4. So this is not allowed. So that's another example where a unique key would make sense for our needs. Okay, so there's a lot to take in there. Alter table. I'm going to push you guys to read documentation because you can, again, alter a lot of different behaviors. So one thing that I purposely left off in my schema. Notice I don't have any not nulls here. We're going to want to have a lot of not nulls, right? Username, for example, you should not be able to create an account with a null username. So now one way I could do it is add not null in here after the fact. So that's going to require me to drop my tables and recreate them. I could do alter tables all day long. Alter table, add a constraint. I'm going to need to look this up, honestly. So Postgres documentation, alter table, null constraints. Let's see what we have. Chartio.com, never heard of this site, but hopefully they have a good example. So alter table, alter column. Okay, so you do it this way. That looks familiar. So again, alter table command, you tell it what table you want to alter. In this case, it's user accounts. User accounts. We want to alter a column in this case. That column would be username. And we want to make it varchar 64, not null. So we're changing it to not null. Initially, we had, where'd my schema go? We had varchar allowing nulls. We're going to say, well, nulls aren't allowed. Same data holds, or same thing holds. If I have any records that have null right now, I need to fix those before I could apply this constraint or this alteration. Let's give that a try. Oops. I think this is not going to be valid syntax. Yeah. Let's look at Postgres docs. There's questions out there, Ivan.
Yeah. Is there a way where you can alter all the like if you just did a star instead of a specific column, would you be able to add not null to the entire table with one command?
I don't think that's possible. I don't think you could do a star for columns like that.
Okay.
But I could be wrong. Again, there's a lot on here. So I'm trying to alter a column name. One of these should be null. Fine, null. Okay, so I want to set not null. That's what I want to do here. So I want to set not null. So again, documentation to the rescue. So we're doing alter column name. We want to set the not null. If we wanted to remove a null constraint, we drop it. So let's see if this gets by my syntax issues. There we go. So now username should no longer allow null values. Again, that goes for a lot of these fields. I've left off not null, so password probably shouldn't be nullable. Last login date can be null, right? So that's design decisions. These are all things we need to decide as we're creating our schema. Does it make sense for this to be null? Yeah. If they're never logged in, last login date should be null. Profile photo, yeah, I guess you're not forced to have a profile photo on Facebook, so that could be null. So that's what you got to do when you're designing your database. Make sure you understand relationships, data types, constraints, all these good things to create a proper data model and schema file. Okay, that was a lot. I know. You guys have challenges today. We'll give you practice with creating schemas. I would say I'm a fan of this diagramming tool. So again, that's quickdatabaseddiagrams.com. There's probably plenty of other similar sites out there, so take your pick. You could probably find ER diagram sites. I think someone mentioned in the Zoom chat that one of the VS plugins has like a diagramming tool. So take your pick. But it's good to get a visual before you actually get to writing a schema, because you want to make sure that you understand the connections and go from there. I don't really want to mention this, but I will. This tool is actually kind of nice because if you go to export, you'd actually export the SQL commands for this. I don't want you guys to rely on this too much. I want you to get practice writing SQL by hand. So maybe I should not point this out, but you can export your pseudocode here into a Postgres SQL format. So you get the actual SQL, but you might need to modify it for like unique constraints and one-to-one relationships, which aren't always easy to do through the pseudocode here. Okay, what questions do you guys have as we wrap up here? All right, so again, 3 easy steps that take some time. Make sure you think about your design, create your entities, and then your relationships. Your relationships, again, are either one-to-one, which is just a foreign key and a unique key together in tandem. One-to-many is just a foreign key, the most common case. Many-to-many, you need that separate table. And that's something that students struggle with sometimes. They're like, well, why do I need it? I could just use a foreign key. Make sure you understand the limitations of a foreign key versus what a many-to-many relationship offers you instead. All right, I'm going to wrap up there because we want to give you time for your challenges. Let me stop the recording.